Well, if you're like me, you might be feeling a little itchy, like I'm learning so much about this gas city, but when am I gonna actually get to use this thing? Uh, and I feel that too. So maybe let's split our time each day into two sections. Number one will be going through docs as we have been, trying to get a better understanding of this thing. But maybe later today I'll do a part two that's just how can we take this thing for a spin? How can we get it to do something that we find interesting? And to do that, I've got a certain project in mind. So we've been using a sort of sample project from a city called Tudor about arranging our bookshelves and the objects on those shelves and things like that. But I have something substantially different in mind, I think, for what we'll do next. So hopefully we'll get to that soon. We're starting here as a recap of what we were doing. These are not the quote unquote 9 concepts of the architecture. This is sort of a puzzling picture that we were trying to figure out. Is there anything significant about this ordering of the various dimensions that you might see in a gas city? And I don't think that we really resolved that by the end. Um, what does this have to do with the layers of configuration? Why are the capabilities in some order? How are they sort of linked to each other or dependent on one another? But what we're going to do to continue going through the architecture is scroll back up to the top. Last time we went over this document, but this time we're going to start diving into each individual detailed design document, architecture document. And the first one we'll look at is session. So if you recall, session, like it says, is it's modeling, um, observing session. Well, not really. Uh, I don't like definitions that use the word in the definition. um, Basically, we're talking about agents. How does Gas City interact with agent providers like Codex or Gemini or Claude? Uh, and this is the primitive, this is the wrapper around all of those agents, regardless of provider. While we're being nitpicky, we might as well continue being our, nitpicky self. And let's just record our objection. And of course, we'll test this statement later. But as far as I can tell, this is what sessions are really about. We want to be able to interact with whatever kind of cognition the user wants to bring or configure. And we don't want to be thinking too much about the different vagaries of the different agent environments. We'd just like to be able to get some normal things out of them. We have this statement again. I think that we sort of questioned this phrase crash adoption. I don't know what that means yet. We'll find out. The runtime boundary lives in internal runtime. Runtime provider is the level of contract that pluggable providers would implement. And so the surrounding pieces that make the primitive usable are internal agent for session naming and startup hints, template underscore resolve. We're building runtime start configs, which again, I'm not sure I know what that means yet. I've seen all of those words before. Internal session for the bead-backed lifecycle projection. This might be interesting to get into as well. Session bead records, waits, block turn state. The important current state split, again, words that I have all seen individually. Runtime manages live sessions. Agent helpers define naming and startup, and session helpers manage higher level session bookkeeping. Okay, and they're telling us sort of the history of this feature, which again, maybe leave out history. Key concepts. Runtime Provider is in runtime.go. It owns session lifecycle, communication, metadata, and observation. Runtime config is the start time config for a session. It includes a bunch of stuff. Startup hints are config side hints that are converted into runtime config. I assume what that means is something like there are a lot of ways to configure an agent and a lot of different levels at which one might do it, like at the rig level, in a pack, or at the city level. And at some point, all of those things need to coalesce into the actual configuration that's going to be used for the agent or session. The name of the session. A startup identification string generated by Beacon so that it's easy to see restarted sessions. Or sessions to restart, I don't know. A config fingerprint that lets us know when we're editing our config, presumably. I don't know what else runtime drift would be about. Startup dialog handling. I don't know what that means. Perhaps it has something to do with the way that different providers start up and how that needs to be handled by Gas City before the agent is ready and waiting to take input. Blocked session and wait behavior. Okay. So I think that we can decide, we can hold off from diving into this code directly, but maybe we'll want to do that pretty soon. Okay. Now it says this is an architecture diagram. It seems to show dependency arrows, but it might also be just a linear timeline. First, we look at the city config. Then we do template resolution. Then we have our agent startup hints and runtime config. Then we pass those to the runtime provider. And there are various different runtimes that you might be running Gas City inside of. And then we start bookkeeping for the session. But it is a little unclear from this architecture diagram whether it's dependencies, timeline, or something else. And Oxford comma, we need to have that in there. All right. It is sort of, yeah, telling us the same story. Start flow. First, this happens. Config and provider defaults. Then template resolve go builds the final command, presumably the command that starts an agent, but I guess we'll see. Overlays, again, I'm not sure what it means in this context. Staged files might be files that are configured as part of the knowledge of the agent, maybe. Then the provider start will get this runtime config. Then it will run. Perhaps it will create or attach to a tmux session. So right now we're running our city out of tmux right here. So here is our mayor session. It's running in tmux. It's a clod. Yeah, there are other ways to run these provider specific. The way that you would attach an agent into one of these environments. K8s stands for Kubernetes. A pod backed session would be one that's occurring inside of a container that's being managed by Kubernetes. I guess the short version of Kubernetes is that when we want to create a resource or like a module that provides a certain API to us, we might stick it inside of a sandbox with its own little file system and its own networking and that kind of thing. And we could set up that sandbox with exactly the tools that it needs to do its job. And it would only be able to communicate in and out of the sandbox through the network interfaces that we have set up. And so it's a very useful tool that one could use to safely isolate different agents or do other kinds of things like that. So perhaps some of that work has been done, and we'll get into that as we learn more about Gas City. Then certain helpers that are sort of doing bookkeeping for Gas City. We have things that you want to do with agents. Start them, stop them, and interrupt them, I guess. Or be in start, be in stop, or be in interrupt. We see if the session is running, if it's attached to an agent. If it's doing stuff, we can look at it. We can interact with it by sending keys. So a lot of our interactions with our mayor has just been sending keystrokes, like thanks. If I hit enter here, then that would be sending keys over to the mayor in this Claude session. Um, Attaching is something that we might do to get into this session. So the way that we entered this session with the mayor was by running a GC session attach mayor, if I remember right. Similarly, we can nudge the mayor without actually attaching to the session, but that will send a message into the session that's running. I don't know what these are about, but presumably it's like sessions have metadata, and we can look at it and change it and remove it. Staging and reapply. I don't think I know what these would be about. Let's see. Primary interactive runtime is Tmux. There are different non-interactive runtimes, script-backed, Kubernetes, like we mentioned. Session names come from agent session name for and must be stable for a given city agent template combination. We talked a little bit about idempotency the other day, and this has to do with sort of identity, right? When we combine parameters into a sort of natural key or unique key, we don't want to find two different things at the other end of that key. And I guess the reverse holds as well, right? Like if we provide a key or provide a few variables to a key, we want to get a consistent name for that thing. Runtime drift detection uses like mathematically secure hashing, if you want. That's better than doing ad hoc field comparisons. So the idea being that like if I've configured my session to look a certain way, and then that configuration changes later, we'd like to be able to detect those changes. And we don't want to do it by sort of guessing or just providing a field at a time, which would be really slow. We can just make a fingerprint for both sides and compare them and see if they are equal or not. Providers must treat stop as idempotent. So this would mean that like if you can't stop a session twice natively, so for instance, like if I control C this Claude session, generally it will die. And if I did that again, then I'd be like putting keys into my shell or something like that. And so the provider has to be able to tell that my stop succeeded on my Claude agent in order to say ignore the second time if I send a stop again. Process alive with an empty process list returns true by contract. I'm not sure why this is important, but it has something to do with defaults. Somewhere somebody needs this to be the truth. uh, so for instance, like we might say that it's sort of in the same way that we consider like the absence of characters, like empty string is still a string, you know. Although in a lot of programming languages, empty string is like falsy, Uh, you could argue whether or not it's the sort of presence of emptiness is there or not. Uh, Now, I think that, for instance, Java programming language, an empty string, like one with no content in it, and a null string are two different things, right? So an empty string could have a name and some other stuff associated with it, while a null string, no memory has been allocated and all this stuff. Metadata is runtime owned state, keyed to the session name. That's interesting. Wait and pending interaction behavior must layer on top of the runtime contract instead of bypassing it. I don't know what that means exactly either. Perhaps it's a feature that go into certain sessions. Okay. I think that we have gone about as far as we can go without actually starting to look at some of this stuff. Let's look at runtime.go. All right. And this is my first Go reading. From what I've been told, it's similar to certain other languages. We'll see how readable it is. Apparently, the agents like to program in this language. So we've got a bunch of imports. So these would be library imports. Um, this package, you can see that it is under the directory runtime, and it's also called package runtime. This is a convention you see in a lot of programming languages where the way that we organize our code says something about which parts of our code are visible to one another by default. And also, like when I want to refer to the functions inside of this code, how do I refer to them? How do I go get them? And in this case, you could imagine some other piece of code importing runtime and then getting all of this stuff out of it, in much the same way that we're importing strings and getting some stuff out of that. We have a lot of error definitions. And apparently these would be errors that, and I don't know if errors is in the Go standard library. We could just have that kind of open. Go, I will say lang standard. Okay, cool. Errors, here we are. So yeah, we'll just have this tab open. The new function creates errors whose only content is some text message. Check. Okay. Is examines the tree of its first argument, looking for an error that matches the second. So this is asking if error is a file system existence error. It will succeed if error wraps error exists. So generally this wrapping idea is the idea that errors can be caused by other errors. And at some point as as we're programming and an error happens, um, perhaps we would surface that up in a certain way, right? Like there's no such file where we expect there to be. So we would throw an error of that kind. And then at the next level, we might, understand that in context a little differently, and we might wrap it in an error that makes sense in that context, and then throw that upward, and so on and so on. And so what this is about is trying to talk about whether or not somewhere in the list, this error includes this idea of existence. First the error itself, and then the tree of its children. For a deeper discussion of the philosophy of wrapping one to wrap. Okay, so I think that's enough though to understand this this file that we're reading. So we want to create new errors that talk about if a session already exists, then we shouldn't create another one with the same name. This one, the infrastructure for a session exists, but it's not ready yet. Callers should retry. A provider doesn't implement the interaction capability. So a certain session interaction would be unsupported. In this one, an error session died during startup. Okay. A session is not found. So if you want to attach or send to a session, but the session is already gone, then that's a bad problem. Is session gone? Whether the error represents a session is not there condition. Either session not found or legacy provider phrasing. So apparently these are certain ones. Now it's funny because we have read some statements elsewhere, especially related to ZFC, Zero Framework Cognition, that have to do with trying not to use these sort of crude matchings to decide if the session is not there. Instead, you should delegate to the inference engine, to the cognition. And so interesting that something like that survived. Okay, we've got content in a message. Type, text, and path. Text context constructs a text block. Where there's a lot of text blocks in our sessions to and from the agent. Flatten the text in a series of content blocks. Interesting. I haven't seen this. It's not totally backwards, but it's a little bit different than C or Java. The way that one highlights that something is a list. There are several. We're getting a bunch of different parts, and we're appending them out of the content. We're trying to see if we have file paths or if we're having text. If they're file paths, then we're getting the text out of the file and then appending that. If they're text, we're just appending that. And then finally, we're joining them back together as a series of paragraphs. That's what this \n is for. Here is an interface. This would be another like Go language concept. I guess what I assume it means in this context is what it means in like the C, C++, or even Java context is right. You provide the sort of inputs and outputs of a function, like start here, without actually providing the implementation of that function. You sort of defer that. And that means that if you come along later and you're like, I'd like to create one of these providers, then I have to create a thing that conforms to this interface, that implements all of the functions it says are in this interface. And so I know that I have a valid provider if I implement all of these functions. And also in particular, here, these are commented at the level of intention, right? So not only should the user coming with a provider get these functions with their names and inputs and outputs, but they're also getting this sort of semantics, like what should the start function do? How should it operate? Well, it's going to give you a new session. Um, and it's going to return an error if a session with the name already exists. Similarly, stop is going to clean up the session. Interrupt is a soft interrupt, like a SIG_int. It can be used for graceful shutdown. Is running. So presumably we have a set of named sessions and the provider is controlling, I guess, a stable of sessions that have been named and might be running or might not be running. And you ask the provider, do you have a session by this name? Is it running? Whether user terminal is currently connected. So this has to do with like, do I have a window like this where I could be typing at my mayor? Attach. Connect a terminal to the session for interactive use. It will block until the user detaches. So I guess this is sort of like, for me, this just makes me remember programs we'd write in C that are like prompting the user for input and waiting until the user provides that input. But in this case, we might attach the terminal to the session. It's going interactively, the user is attached, and then anything that we need to do after the user is attached, um, you know, that's when this function will return. And then we can go on and do things. It's interesting that I'm rereading this, and it sort of looks like a lot of these just are returning error, which is kind of interesting. These seem to be types that are being returned. So isRunning is a Boolean function. This is an error function, which I assume means that normally it just would return without doing nothing. Like it says, returns nil, or it returns error, and you might look at that error. Let's see. Does the name session have an agent process matching one of the given names in its process tree? It returns true if this is empty, but it would also return true if there was such a process name inside of that session. I don't know exactly what processes the sessions are starting that it's looking at that one would want to call this, but I guess we'll maybe see that later. Nudge. Send structured content to the session to wake or redirect the agent. Yep, it's just going to use text content to wrap any plain string in this content block. Store key value pairs, used for drain signaling and config fingerprint storage. I don't think we've talked about drain signaling much. I happen to have run into this in a sort of different context. But maybe it would be like, hey, it's time to go. Do whatever you need to do to hand off, I suppose. And perhaps you would be looking at that key value pair to do that. These ones sort of go together. They're sort of a piece with that. Peak captures the last n lines of output from the name session. So we did see this one. We have seen some of these as commands in GC session, right? So we haven't done any session starting, but we have done GC session attach. We have nudged. We have peaked at a session. Get the time of the last activity. Okay, this is interesting too. This is returning string or error, it looks like. Or perhaps it's string and error. It's a little unclear just from this syntax, but perhaps error would be empty and string could be some scroll back. Returns the list of names of all running sessions whose names have that prefix. Could be empty. Um, perhaps an error can be returned. Return 0 time if unknown or unsupported. So yeah, I'm going to assume, I guess, that this is the way that you um, return multiple outputs from one function in Go. All right. Clearing scroll back. Used to give a clean slate after an agent restart. This kind of makes sense. Like the agent has forgotten everything, and so you want to forget everything too. You don't want to be able to peek at the agent and see a bunch of lines that were associated with an old session that are no longer available, relevant to that agent. Copy. Copy the source into the name session's file system relative to the current working directory. Um, it's used for ad hoc post-start copies. Um, there are times when I've done something like this before, but usually what I'm doing is copying the contents of a file into a prompt, not usually like copying a file directly. Send keys sends bare keystrokes. Sends raw key events without appending enter. Nudge sends enter. Send keys just send stuff. Used for dialog dismissal and other non-text input. Returns nil if the session won't exist or the provider doesn't do interactive input. That makes sense. And it seems like you should be able to implement nudge in terms of send keys, right? If the only difference is you're going to send the same bare keystrokes and then enter. Although, yeah, like it says, this is, I'm not sure exactly what this means. It's not an array of strings. Let's look that up real fast. Golang 3. Variadic function parameters. Okay, so that kind of makes sense. Um, if the last parameter has type ... t, it can be called with any number of trailing arguments of type t. So let's look back at that. Oh, sorry. There we go. Okay, so this could be like you could imagine calling send keys with a name and then with a key, comma, key, comma, key, comma, key. Yeah. So that's what that is. I don't know why you wouldn't just do this as an array, but maybe it was convenient at some point to do that instead of um, as here, right? Like sending an array of content block, an array of process names, right? This could have been done the same way, right? With process names, ... string. It's the final parameter. You could have process name, comma, process name. It seems like a stylistic thing that there's two ways to do that same thing. I think normally, personally, I would probably prefer this way. Like you're always constructing a list, but then it's totally ambiguous how many arguments this has. If I want to add a third argument after this list of strings, I can do that really easily. If I add another argument after this, I'm pretty sure that's an error because then we'd have a ... argument before some other like static numbered argument, and you wouldn't know like what place to find that other argument in. Like you wouldn't know, say, what cell of the arguments of this function to go looking for, uh, some other parameter because you don't know how many keys there are in the list. Let's see, run live. I don't know what this means. I guess we may find out. Capabilities reports with this provider can reliably detect. Used by the reconciler to skip inapplicable wake reasons. That seems really specific. I don't know what that's about either. Perhaps it has something to do with what actions can I take on the provider that will cause it to be interactive, that kind of thing. All right. We have only gotten about, let's see, maybe a third of the way through this file out of 500. It's interesting that it should be like exactly 500 lines long. Yeah, about a third, 2/5. What we're trying to learn, I guess, is what are sessions made out of? What can you do with them? And then, we'll understand, I guess, like what model Gas City has of a provider behind this sort of interface of the session. All right, pending interactions. Some providers allow structured approvals, questions, or turn blocking prompts. Okay, I believe it. A blocking interaction raised by a session. So it's the other way around, right? This is like not coming from the user to the session. Like every provider allows the user to ask a question, but these sessions, they're sort of like, do you want me to do that now? I need more information. Please provide X so that I can do the job that you asked me to do. And so that would be this, coming from the robot back to you. I try to say agent. I don't always say robot, but I kind of use them interchangeably now. Okay, and then the client, that's you, or perhaps like the whatever agent is trying to get something out of this session. Um, it's sort of weird to think about agents running agents, but that could be a way that they intend to like work with each other. Like especially as they become more specialized. I mean, certainly I would have this kind of interaction with people a lot, working on call activities or something like that. Like, um, I'm working on a ticket, and it's like, hey, I need you to do X, Y, Z, or I'm having this problem, and they might respond to me, hey, I need this information to further investigate your issue. Stick my ticket into, waiting for a customer or waiting for a client, that kind of thing. And then I would be on the hook to respond to that so that they could continue to go on and do their job. Some providers could surface and resolve pending session interactions. I guess there's probably like an interface where it's like, I've opened 4 questions against you. Please resolve those in any order and let me know when you're done. Just a moment. Okay, hopefully, I don't know if I've set up my audio in such a way that when I mute my microphone, you can hear it through the desktop audio anyway. I guess I'll find out when I watch back the video. Almost sneezed, but hopefully not bothering you. Okay. Idle wait provider. Some runtimes can wait for a safe interactive boundary before input is injected. I think that is a normal thing that I see in my Claude sessions where I am working with Claude and then I type in a command and it doesn't respond to me right away. It's still working on something that I already asked it to do. And when it gets a free moment, then it will come back and respond to me. and it looks like there's certain like time requirement that we could put in here. It's like if we see our agent spinning our wheels, that kind of thing, then we want to get out after a certain point. And that could be important in some contexts, like I need an answer right away, or I need to make a decision inside of the framework, and I don't want to use this in plumbing. I'm calling you because I need you to do something, some pending operation for Gas City. I don't think this is always about interactive sessions with human. So I guess what I'm saying. Some some of these runtimes, some of these agent providers have known startup style dialogues. And so you can try to work to get around them. Like all of these sort of the tools that assume that you're interacting with them directly. They might want to put something in front of you to say, hey, please accept the terms of service, or, your privacy options have changed or something like that. Press OK to acknowledge. And if we're not intending necessarily to interact with those directly, if we really just wanted to get a prompt and do some work, then those things are kind of in the way, right? They're standing in between us and the cognition resource that we want to use. And so you might want to dismiss a known dialogue if you know what it's about. Maybe you've already answered that question a million times, or you're not using the tool in such a way that there would be a human reading this message anyway. Do we support starting sessions with a specific transport? I don't think we've defined transport yet. We can see some references over here. I haven't been trying to look at this very much, but it's something that we could be doing, right? Like we could find out who calls support transport, and we'd find them over here, like certainly the command session. So we haven't talked too much about the relationship between this and this. Like I sort of alluded to it in passing. We've attached to GC sessions before, we've nudged them before. But this is where the actual implementation of that would go, right? It would use this provider. And when we call the GC command and we call session, GC session, and then we provide these arguments like nudge or attach or whatever, then it would go and implement that in terms of this interface. Immediate nudges is contrasted to this, wait for idle. Discard the interrupted user turn without restarting the session. Gemini needs this after Control C. You can't just cancel a generation. It might answer both requests. New to me. I haven't used Gemini. Codex emits a turn aborted marker when an in-flight turn has been canceled. It's good to wait for that marker. So sort of inside baseball about those quirks of different providers. You can see that the provider is kind of leaked up into the interface a little bit. Not all the providers need this, but a couple of them do. And their quirks have made it all the way up to the interface. But apparently that's required. It couldn't be implemented underneath one of these other functions or something like that. stage in those sessions working directory before the agent command starts. So this has to do with like preparing the ground for an agent. And I don't know when you do this, but it might have something to do with the agent configuration that we set up, either from our packs or in our rig or city configuration. Probed indicates this was discovered via file system probing rather than from config. We don't want to have spurious config drift when files are recreated with identical content. Interesting. Content hash. Hex encoded hash of the entry's content at discovery time. The config fingerprint will be stable. A SHA-256 hash of the content. So this is sort of like how we're able to tell if the content has changed or not. So SHA-256, this is an algorithm that makes a sort of strong guarantee that if we pass in a certain input, and we'll get a certain like output hash, you could say. So you could almost say like a pseudo random string that shouldn't match if we pass in a different input, right? And so if we pass in two different inputs to this hash function, then probabilistically, but with a very high degree of certainty, like all the atoms in the universe kind of certainty, that kind of thing. If you pass in two different inputs, then you'll get two different hash codes. And why that's convenient is that instead of doing sort of complicated checks for equality, you can do a very simple check, which is do the two hash codes, which are substantially shorter than the content as a whole, right? If these two hash codes are different, then all of that content, there must be some difference, and that's useful for understanding whether we need to reread that content to reuse it, or whether we consider the updates to be ignored or have happened or something like that. Callers should treat as unknown if you don't have a hash. So especially if you're trying to do something like determine inequality, and you get a hash code for, say, the old version, and you get empty for the new version, you shouldn't feel like you know whether they're equal or not. And it's looking at all of the files, adding all of the content, and then finally, this is sort of familiar from C related languages. This exists in Java as well under the name string.format. This I think would be hexadecimal format, whatever this data is, as a hexadecimal, as a base 16 encoded, and get the hash sum of that. I'm sort of looking for where the hash itself is invoked. Ah, here we are. So we have this guy, and we're constantly feeding data to it. Feed it, feed all of these bytes and things. And then finally, when we're ready to do this sort of checksum or do this hashing function, then we pass it through. It's interesting that it's looking for really specific Python files here. Or these would be Swift, maybe? I'm not sure. are we supposed to skip? Oh, these might be like Python compiled. Um, Maybe these as well. Uh, why you would want to skip them is that they're already themselves like long binary data. Maybe they won't add much to this check. And you might not want to do like hashing equality on long binary data. Just as a guess. We could look this up and learn more about it. The config needed to start a new session. This is helpful. What's the working directory going to be? What shell command shall be run? What environment variables shall be set? What MCP servers are available? We haven't talked about this, but there's MCP stands for Model Context Protocol. It's a standard for how agents should interact with other systems, including potentially other agents, but often like say that you have some data in a database. There might be an MCP server that wraps the data in your database, or wraps the MySQL, something like that. Um, Especially for third-party like software as a service providers, there might be an MCP server for the Jira system or the Notion wiki system or Google Docs or something like that. And so when you provide a bunch of MCP servers to a session, you're saying these tools are available to use. It's not necessarily that it will be used inside of the session, but if you ask the session to do something with that tool, it would be ready, configured, and available. Yeah. Startup reliability hints. A ready prompt prefix. This is like I can know that the session is ready to take input when I see this prompt prefix. This is the one from Claude. And here we can actually see it right here. Ready delay milliseconds. How long in milliseconds, ms, conventionally, are we going to wait until we just start trying to input commands into the session? What expected process names will there be for this particular provider? So for instance, the process name for Claude Code is Claude on my Linux system. Does the agent show a bypass permissions dialog? That would be important to know if you want to skip standard bypass permissions dialogs. And I don't think I've totally mentioned this yet. You can see in our mayor session, bypass permissions is on. That means that it has kind of the run of the store. It's not exactly a safe way to operate. Um, I'm running this inside of a VM, and so it's possible that I'll be able to like restore my VM. It could go and trash the place. But yeah, this is sort of like the most extreme amount of permission that you can give to an agent. We can set them into planning mode. We can set them into accepting all edits. Bypass permissions is a particularly long one, which is like you can do any command you want on this system. It's like go nuts. And that can be good if you want it to have freedom to get things done. It's needed to remove the human out of the loop to approve if the agent wants to do a sort of novel command that is for whatever reason flagged by the safety system of, say, like Claude or the other agent system. Bypass permissions will just go, don't worry, I'm already the emperor of this system. We know about nudges used for CLI agents that don't accept command line prompts. That's an interesting way to put it, I guess. I guess this is so a slightly different definition of nudge than we've been using, right? Because normally nudges are one shots that are used into the session. Um, they will just send a message and then the session will continue without us, right? Sort of a fire and forget kind of thing, uh, as opposed to one that if we don't have a command line prompt, um, then that means that we need to prompt the agent as it's starting up. And so I guess that maybe this would be better named like startup prompt or, manual startup prompt, something like that. Pre-start. A list of shell commands run before session creation on the file system, used for directory or worktree preparation. Agents never launch into an unprepared working directory. That's good. I can imagine certain instances where I don't want to run an agent of a certain kind without its, ready set up tools, file system, sandbox, that kind of thing. A list of shell commands run after session creation, between verify alive and nudge. Again, like a manual prompt start or something like that. Session setup script, a path, run after session setup commands. I'll believe it. I'm sure it does something. We're seeing a lot of hooks into the setup sort of system. Session live. Shell commands run at startup and reapplied on config change without restart. Typically using tmux theming, key bindings, status bars, and so on. This is cool. It's sort of allowing the session to react. So you can imagine like if I had more interesting things going on in my session, perhaps it would be nice to be able to have those things updating live instead of forcing me to restart the session or start a new session to get those changes. Provider name, e.g. Claude, Codex. There could be a lot of reasons to have the provider name. This one it says is for overlay filtering, but it seems like you could dispatch a lot of data off of, or a lot of changes off of that name. Almost there, and I've got to stop around 4, so I think we're gonna make it though. The end is in sight. Installing agent hooks. Interesting. This has something to do with running 2 agents at once. An agent running Claude can still get the Gemini settings. I don't know under what circumstances that is interesting, but maybe that's important. Maybe that's an agent running Claude that can go and use your Gemini settings to interact with Gemini sessions. That's kind of weird, but I assume there's some feature that needed it. I also feel like I'm not writing feedback for this section of code because we're kind of speculating about what it does. And we may see the rubber hit the road, right? When we're like, you know, where are these things being used? Yeah. So this is used on session start, for instance. Pack overlay DIRs. So we're getting pack level files. So packs, I guess, if you don't remember from earlier videos, they are sets of configuration that are sort of standardized and intended to be shared, and they can include startup files for an agent, right? And so you could imagine that there's some overlapping configuration that would happen there, where we have the pack might provide some files to the file system. Um, the host might apply some files to the file system over and above the pack. There's a priority written in here, but this is a sort of weird way to write such a priority, right? Um, like we're sort of reading that there is a list of overlay ders here, and then there's another one that is also supposed to overwrite all of those. Um, one could imagine that we had instead like a list of overlay ders that was constructed uh, by a certain outside process that was ordered. So that, say, the highest priority one would definitely win, and then the later ones would, fill in the gaps or something like that, or the other way around, that the lowest priority ones go first, and then they get overwritten by all of the ones that are of higher priority until the highest priority one overwrites all the ones that have come before, right? And so this may be a theme that we'll see again, but it has to do with whether you are writing this kind of behavior into the type system, right, of this configuration, or whether you locate it somewhere else, right? Like it's sort of like if you have a bunch of pack overlay ders, do this, and then if you have an overlay dir, do something different with it. When really we're trying to do the same thing with both of these things. We're just trying to prioritize this one. And so that's a little funky. Copy files. Which files or directories should we stage? So this also has something to do with these uh, overlay ders. For local providers, we're copying stuff into the local working directory. For remote providers, like running inside of a container or something like that, then files are transported into, e.g., the container. And I said container, referring to like Kubernetes container. A small little atomic file system / CPU system that is sandboxed away from all of the rest of the stuff you're doing. All right, fingerprint extra. Config data that should participate in fingerprint comparison but isn't part of the session startup command. Interesting. I'm sure that that is important. It's like we want to know if certain configuration is changing, but we don't see it inside of the session startup command, which is curious. Again, you sort of go, well, why wouldn't it be in the session startup command? Is it always dynamic? Is it always calculated or something like that? You could perhaps, construct it into the session startup command instead of doing this kind of stuff. I've never seen this before. This is Go syntax for map, I guess, which usually means like key value pair. And this would be map of string to string. Okay. Prompt suffix. Prompt text that was appended to the command when starting the session. It might contain volatile data. Prompt flag. It might be needed for certain providers that you pass an argument like -- prompt when you're doing the startup command. Like it says, when it's empty, then it'll be a bare positional argument. Might need to be stored separately. This is sort of a quirk of tmux. Again, it's sort of like, do you want to throw the quirks of the system into the interface? Finally, sync workdir env. It gets the config out of the working directory. Again, not sure exactly how it will be used. But okay, I think what's nice about what we've done here is that we've kind of seen everything that sessions have to offer. We can go look this up again later, but basically like all the things that we could do with sessions, all the ways that we might configure them, uh, all of the things that are interesting about them. And we're sort of starting to build our mental model of what do we need, how do we need to be able to interact with providers in order to add another provider into Gas City. Um, what are the kinds of things that they need in order to sort of solve this problem of interacting with a session without always needing to have a human in the loop? What are some quirks and differences of different providers as they provide their sessions to Gas City? So hopefully that was helpful. And now let's see if we can go back through and learn a little, skim through this and see if we understand what's going on here in session. Um, yep, we did look at provider. We can look at config again. I think we did actually technically. Runtime.Config is down here, right? Yeah. So we looked at, here we go, runtime.Config. So we looked at these. We haven't looked at agent, and we haven't looked at beacon, but this is sort of a kind of small thing, I think, in the grand scheme of things. We've talked about runtime drift a little bit. I think we understand that. There's dialogue handling. Might not be that interesting. It is sort of inside baseball or like papering over an inconsistency in the sort of protocol offered by the different cognition providers. Like, we wouldn't have to do all this fancy dancing if they just allowed us to interact with them all according to a certain standard, right? Certain block session and wait behavior have to do with this is when the agent is asking us a question, we need to respond, that kind of thing. Cool. Yeah, I think this particular one's making a lot more sense to me now. I hope that's true just as much for you. We've got these different runtimes. We haven't done anything with that. I don't think we've gotten through all the invariants yet, but at least we're starting to kind of draw ourselves a picture of that. So with that, I think we're going to stop there with session, and hopefully we'll continue getting some more insight into the architecture with the next topic, which is going to be bead store. So I'll catch y'all later, and hopefully next time we're going to have a practical session where we actually take this city and try to make it do something interesting. So I hope you'll join me then. Thanks much.